Hello, it's Carly McAvoy. I'm talking about a couple of problems today that give students difficulty, so I want to go through those. One of them is an investment problem, and the other one is a solution or mixture problem. Both of these can be solved using a system of equations. And that means we have two unknowns. So here's a typical one. Juan invested a total of $5,000 in two accounts. One account paid 7.5% simple interest and the other paid 6%. At the end of the first year, Juan earned $340.50 in interest. How much money did Juan put into each account? So it's first very important to declare your variables. I'm going to say that X equals the dollars invested in the 7.5% account. And Y, I'm going to say are the dollars invested in the 6% account. And whenever I talk about a percent in a problem, I'm going to rewrite that as a decimal. 7.5% is 0.075. and 6% is 0.06. I could put a 0 in the end, but I don't really need to do that. So the first thing we know is that the two accounts had a total of $5,000 invested, and so the money invested in X and the money invested in Y should equal $5,000. The second equation has to do with the amount of interest that they get. So for the first one, they put 0.05% interest. And simple interest just means at the end of the year, they give them 7.5%. So we multiply the amount invested times the interest. And then for the second one, they put 6% in, or 0.06y. And that was equal to $340.50. That's how much interest they earned. So the first equation has to do with the money in the account, and the second one has to do with the interest that they earned. So what I'm going to do is rearrange this top equation so that I can substitute. So I'm just going to subtract X from both sides. And do you see that that would be Y equals 5,000 minus X, just by moving the X to the other side there. Then I'm going to come down to this equation, 0.075X plus 0.06, and instead of Y, I'm going to put what Y equals, which is 5,000 minus X. And that's going to equal $340.50. Okay, so now I can solve this equation with just one variable in it. 0.075x plus 0.06 times 5,000, that would be 300. You can use a calculator for that. And then minus 0.06x, and that's still equal to $340.50. 0.075 minus 0.06. I've got 300 plus 0.015x, just combining my x's together. Then I'm going to subtract 300 from both sides. 0.015x equals $40.50. Divide both sides by 0.015, and I did this earlier, and I get 2,700. What is 2,700? 2,700 is the amount of money invested at the 7.5% account. So 7.5% account has $2,700 in it. How much does the other account have then? Well, it's this, 5,000 minus 2,700, and that would be 2,300. So the 6.0 account has $2,300. Make sure when you give your final answer that you've clearly stated which account has which amount of money. Don't just say 2,300 and 2,700 and hope for somebody to figure out which account you're talking about. Okay, the second one has to do with a solution. How many liters of a solution that is 8% acid should be mixed with a 20% solution to get 24 liters of a 12% solution. Well, I always draw the picture, and if you've watched me do these before and you don't need any help, then you don't need to finish watching this. But I have a big vat, and I'm mixing two different solutions into it. So I have two different sources coming in. And I'm going to call the 8% mixture X. And I'm going to define that as X at 8%. I have X number of liters at 8%. And then I'm going to put in more liquid, and I'm going to say I have Y liters at what percent? Well, at 20, because I'm adding in a more acidic solution. So I'm going to increase the acidity by going from 8%. I'm going to add up 20%. What do I have when I'm finished? Well, when I'm finished, I have 24 liters, because that's what it says I wanted. And the new acidity needs to be 12%. So this is the outcome that I'm hoping for. And what's inside is what I'm pouring in, right? So I know that I have X plus Y, some number of X and some number of Y that has to add up to 24. Then I also know that I have my percentages. And it's a little nicer up here on the first one when they gave us the exact interest. We kind of have to figure out our solution ourselves. We're going to take everything in this equation and multiply it by its percent. So I have 0.08 for X. I have 0.2 for Y. I can also call that 0.20. And then for the 24, I have 0.12 for the 24 at the end. So I took every variable here and I multiply it by its percent. 8%, 20%, and 12%. And I wrote it over here for now because I'm going to multiply this whole thing by 100. Why would I do that? Well, I want to get rid of the decimals. So I'm going to move that over twice, and that's going to give me 8x. I'm going to move this over twice, and that's going to give me 20y. And I'm going to move this over twice, and that's going to give me 12 times 24, which is 288. Now I want to add these two together, but nothing would eliminate. I'm not doing substitution this time, I'm doing elimination, but you could use whichever method. So I want to multiply this top equation by -8 and then put it down below here. So -8 times x is -8x, -8 times y, -8y, and -8 times 24 is -192. Now I'm adding these two equations together. I don't care about that top equation. I multiplied it by -8 so that I could eliminate these variables. So that goes away, and I get 12y, and 288 minus 192 is 96. And then I'm going to divide both sides by 12 and get y equals 8. What does 8 mean to me? Well, y was the number of liters at 20%. So I have 8 liters at 20%. How many liters do I have at 8%? Well, I have 24 liters altogether. And x plus y was 24. So now I know that y is 8. I can easily plug that in and figure out that x has to be 16. So I have 16 liters at 8%. So I, again, stated my answer very clearly. Okay, have a fantastic day, and we'll see you next time.